මේ වීඩියෝ එකේ මම කරන්න යන්නේ මම 2021 A level batch එකට මගෙන් ඉගෙන ගන්න අයට මම weekly test එකක් දෙනවා paper එකක්. ඒතර මේ paper එකේ discussion එක තමයි මේ වීඩියෝ එකේ මම කරන්නේ. එතකොට දැනට ඔයගලන්ට මේ paper එක පහළ link එකෙන් download කරගන්න පුළුවන්. වීඩියෝ එක බලන්න කලින් පටන් ගන්න කලින් link එකට ගිහිල්ලා paper එක download කරගන්න questions ටික බලා ගන්න. ඊට පස්සේ මම ඒක දැන් මේ questions ටික මෙතන discuss කරනවා. මුලින්ම අපි discuss කරන්න යන්නේ combined mathematics paper එකේ combined mathematics part 1 paper එකේ part A. ඒ කියන්නේ කෙටි ප්‍රශ්න 10. එතකොට paper 1 එකට අදාළව first question එකෙන් අපි පටන් ගමු. ඒක කියලා තියෙනවා x plus 1 and x minus 2 are factors of the polynomial f of x. ඒතර polynomial එකක් දීලා තියෙනවා f of x equal ax cube plus bx square plus x plus 6. So this is the polynomial given. Then we have to show values of a and b according to the data. The data are x plus 1 and x minus 2 are factors. X minus 1 and x plus 1 and x minus 2 are given as factors. So we know for a polynomial, if x plus 1 is a factor, we can equate this factor to 0 and find the root. That means the value of root, value of x as minus 1. Therefore x equal minus 1 is a root of this polynomial. Then from the theorem we know, if x equal minus 1 is a root, of f of x, then f of minus 1 becomes 0. So this is a theorem. Then let us substitute minus 1 for x. Here we get minus 1, this is plus 1, minus 1 plus 6. This is equivalent to 0. Then answer is a minus b equals 5. This is the first equation. Then they have given another factor, that is x minus 2. Therefore we can equate x minus 2 to 0 and get the root, that is 2. That means f of 2 is also 0. From this theory I can substitute 2 here. It becomes 2 cube plus b times 2 square plus 2 plus 6. This is 8a plus 4b plus 8 equals 0. f of 2 is 0. I can divide each and every term by 4 and subject a and b. Then we get 2a plus b equals minus 2. This is my second equation. So here we have to solve equation 1 and equation 2 simultaneously to obtain a and b. For that I can add 1 and 2. Add 1 and 2. Then we have a plus 2a, 3a. Minus b plus b get cancelled. 5 minus 2 is 3. Therefore the value of a is 1. So they have given a as 1. Then substitute that answer in equation 1. 1 minus b is 5. Therefore b is 1 minus 4 minus 5. Answer is minus 2. So we have shown the two values a and b. Then we have to obtain the other factors of f of x. If you want to obtain the factors of f of x, then we should know a and b. We have already shown them. So our new f of x is x cube plus minus 4x square plus x plus 6. with the values of A and B. We were given two factors of this cubic expression. They were x plus 1 and x minus 2. Here the index of this polynomial is 3. That means we must have 3 factors. If it is a quadratic equation, we have only 2 factors, 2 roots and 2 factors. So what is the factor, remaining factor? For that we have to expand these and compare the values with left hand side. So we have one x cube term here. So we get x cube terms by multiplying this first term with this first term, and whatever the x term we have to write here. So multiplication of these 3 terms will get x cube. X into x is x squared, so we have to multiply x squared by another x in order to get 1x cube. So first term is x. Then we have to consider the numerical term. Numerical term is plus 6. Numerical term is obtained by the product of these 2 terms and the product of that answer with the constant we have to write here. From this multiplication we get minus 2. So minus 2 into which number will give you plus 6? That is minus 3. Plus 1 into minus 2 minus 2. Minus 2 into minus 3 plus 6. So this is the new factor. These are the 3 factors of this polynomial. Second question. So here they have given a complex fraction. We have to separate this fraction into its partial fractions. So according to the theory of partial fractions, first we should know what is the degree of the expressions in denominator. Here we get x square term. When multiplying that from x, we get x cube. So the degree is 3. Numerator, the degree is 2. If the degree of denominator is greater than numerator, we can directly start our separation. For each and every linear factor, we have to write a constant. When we have a linear factor raised to a different index, we have to write that factor raised to 1, that factor raised to 2 until we get this index. So here the index is 2, so we have to write x plus 1 to the power 1, x plus 1 to the power 2. For each we must have a constant. Then the next factor is x plus 2. Now multiply all the terms from the denominator, from this denominator. Then x plus 1, 1x plus 1 get cancelled. We are left with x plus 1 and x plus 2. b into x plus 2. c into x plus 1 square. Now expand for our convenience. This is not essential. Expand. X square plus 3x plus 2. No need to expand x1. Expand this x square plus 2x plus 1. Now we have to compare coefficients of different terms. Starting from the highest term, x square term, the coefficient here is 2. Here we get a coefficient capital A and C. This is the first equation. Then comparing x terms. Here we have 1x, coefficient is 1. Here we have 3a, bx, coefficient is b. There are 2c. Equation 2. Then compare constants. Here the constant is plus 1. Here we get 2a, 2b, and c. This is my equation 3. Now we have to use these 3 equations to find a, b, c separately. If I add 1 with 3, equation 1 plus equation 3. 2a plus a, 3a, 2b, no b term here, c plus c 2c, 2c, 1 plus 2, 3. This is equation 4. Now compare equation 4 and 2. 3a, 3a, 2c, 2c. They are common. Now I can subtract equation 1 from equation 2 from equation 4. 3a minus 3a, 0. 2b minus b, that is b. 2c minus 2c, 0. 3 minus 1, 2. So b is 2. Now we have to find a or c. Now I can substitute b in equation 2. From 2 I get a separate equation, 3a plus 2c. Substitute 2 here, then shift 2 to that side. Answer is minus 1. This is equation 5. A term and c term is in equation 1. So I can subtract twice of equation 1 from 5. When I multiply this equation by 2, I get 2c terms. Then I can cancel with this. So 5 minus 2 times 1. 3a, 2 times 1 is 2a. So 3a minus 2a is 1. 2c minus 2 times 1. 2c get cancelled. Minus 1 minus 2 times 2, 4. That is minus 1 minus 4. Answer is minus 5. From equation 1 we can get c. C is 2 minus a. What is a? That is minus 5. Here minus minus becomes plus. 2 plus 5 is 7. Therefore we can write the partial fractions. A is minus 5. Minus 5 over x plus 1. Then b is 2. 2 over x plus 1 whole thing square. And c is plus 7 over x plus 2. This is the answer to question number 3. Question number 3. So they have given a trigonometric identity. In left hand side we have only x angles. Here we have 2x minus alpha. What is alpha? They have given in the question tan alpha as 4 over 3. We can start our simplification from left hand side, but I prefer starting this identity from right hand side because we have a minus b, cos a minus b formula in right hand side. Right hand side equals 10, that is cos a minus b format. Here write the expansion of a minus b. Cos a, cos b, we have minus, this becomes plus, sin a into sin b. A is 2x, b is alpha, and plus 5. Now we have to substitute two values of sin alpha and cos alpha. From tan alpha relationship we can find that tan alpha is 4 over 3, which is opposite of adjacent. Then hypotenuse is 5 from Pythagoras relationship. So sin alpha opposite over hypotenuse, cos alpha adjacent over hypotenuse. So you have to write this part in your working. Cos 2x, cos alpha is 3 over 5 plus sin 2x, sin alpha is 4 over 5 plus 5. Now remove the brackets. 2 times 3 becomes 6 plus 2 times 4 is 8. 8 sine 2x. Here we have plus 1. Now we have to convert these 2x trigonometric ratios to x trigonometric ratios. So we have to change 2x to x. How to convert that? We know cos 2x, that is cos squared x minus sin squared x. Then sin 2x is 2 sin x cos x. And another thing, in left hand side we don't have a constant. That means we have to convert this 5 to a trigonometric ratio. I can write 5 as 5 into 1. For 1 I can substitute sin squared x plus cos squared x. Sin squared x plus cos squared x is 1. Now expand 6 cos squared x, and here we get 5 into cos squared, 5 cos squared, 6 plus 5 is 11. It's 11 cos squared. 6 into minus sin squared, minus 6 sin squared. Here we have plus 5 sin squared, then result is minus sin squared x. Then 2 into 8, 2 into 8, 16 sin x cos x. Here we have 16 sin x cos x. This is the left hand side. This is question number 4. So this is a limit question that we have to show the value is equivalent to half. Limit value x tends to 5. 1 plus cos x. In the denominator we have 5 minus x. So when we substitute 5 for x, we get 5 minus 5, that becomes 0. So denominator is 0. We know when the denominator becomes 0, the fraction becomes not defined. So it is not half. That means we have to cancel this 5 minus x fraction, 5 minus x factor, which is the not defined factor in this particular fraction. For that, I will substitute 5 minus x as y. So this is my substitution. Let 5 minus x equals 5. Now we are going to change this question to y. Then we have to change the limit into y as well. So when x tends to 5, then y tends to, for that we have to take x as 5, then 5 minus 5 becomes 0, then y tends 0. Now change the question. Y tends 0, 1 plus cos x. So instead of x I can write 5 minus y over 5 minus x is y. It is y square. 1 plus cos 5 minus y. Cos 5 minus y is, ratio doesn't change, cos y. So cos 5 minus y is in second quadrant. We know second quadrant cos values are negative. In first quadrant all the ratios are positive. In second quadrant sine ratios are positive. Then cos ratios become negative and this becomes minus. From trigonometry, 1 minus cos y is 2 sine squared y over 2. This is obtained from cos 2 theta formula. Cos 2 theta is cos squared theta minus sine squared theta. Cos squared theta can be written as 1 minus sine squared theta. Then this becomes 1 minus 2 sine squared theta. This is cos 2 theta. Now take 2 sin square to left hand side and shift cos 2 theta to the other side. Therefore 1 minus cos 2 theta is 2 sin theta. Half of this angle. So for 1 minus cos y, I can write 2 sin squared half of that angle. That is y over 2. Then 2 is a constant, take 2 out. Then in limits we have a theorem like this. Sin theta over theta. When limit of theta tends 0, our answer is 1. So we can apply that theorem here. How? We have to write this same angle in the denominator. Y over 2 in the denominator. Since we had sin square, we have to put square. Then this is sin square y over 2. It is what we had in the numerator. In the denominator we get y square over 4. But in actual denominator we had y square. No 4. So to cancel that we have to multiply our denominator by 4. Because we have written 4 in the denominator part of this denominator. So we have to cancel that 4 by multiplying the denominator by 4. So from this theorem, this is 1. 1 square is 1. Then 2 into 1 over 4 becomes half. That is the answer. Question number 5. So this is an inequality problem. So we have to take this part as y1, this as y2. Initially we have to take only the modulus parts. Modulus part is x plus 1. Then equate that to 0 and find the value of x. X is minus 1. Then we have to take what is the value of y1 when x equals minus 1. So when x equals minus 1, this bracket becomes 0. Answer is 1. Then we have to find the functions of y when x is less than minus 1 and x is greater than minus 1. For that we have to use a convenient value from this range, x less than minus 1. So we can take minus 2. Then substitute minus 2 in this bracket and see whether it is positive or negative. We are just checking whether that bracket x plus 1 is positive or negative by substituting a convenient value for x in this particular range. So substitute minus 2 here. Minus 2 plus 1 is minus 1. So what is the sign? Minus. Then minus into minus becomes plus. Therefore, simplify, remove the brackets and you will have the function plus x plus 2. This is the function. Then take a convenient value in this particular range. Greater than minus 1. We can take 0. 0 plus 1 is plus 1. That means this bracket becomes positive. Now simplify. We have minus x minus 2. This is plus 2 plus 1 minus 1 get cancelled. Function is minus x. Now take the other part, y2. Equate this modulus bracket to 0. 2x minus 1 equals 0. We have the value of x as half. Now we have to find the value of y2 when x equals half. So when x equals half, this bracket became 0. Then the functions when x is less than half and x is greater than half. When x less than half, we can substitute 0. Substitute 0 here. It is only minus 1. So the bracket is minus. Multiply this bracket by minus. Function becomes minus 2x plus 1. X greater than half, we can substitute 1. 2 into plus 1, 2, 2 minus 1, plus 1. Answer is plus. Bracket becomes positive, that is 2x minus 1. Using these functions, we can draw the graph. First, find the coordinate. x is minus 1. For x minus 1 we have the y value, that is plus 1. So this is the coordinate somewhere here. Then the function x plus 2 is for the value of x when it is less than minus 1. X less than minus 1 is this region. What is the function? X plus 2. Gradient is positive, plus 1. Intercept is plus 2. So gradient positive means increasing graph like this. Intercept is plus 2 somewhere here. So we have to draw that line in this region. That means in the region when x is less than minus 1, left of minus 1. Starting from 2, put a dotted line until we get the coordinate and extend this. So this is my line x plus 2. Then when value of x is greater than minus 1, the function is minus x. That means intercept is 0, gradient is negative. Decreasing graph like this. This is minus. Then for y2 the coordinate is half and 0. When x equals half, somewhere here, y value is 0. When x is less than half, this side, gradient is minus 2. In decreasing line, numerical value is 2. Here the gradient is 1, minus 1. So the gradient of this line that we have to draw is steeper than this line. Intercept is plus 1. So this is the intercept. This is the starting point. Draw the line. So this is minus 2x plus 1 line. Then when x is greater than half, gradient is plus 2. Intercept is minus 1 somewhere here. So we have to start from minus 1, dotted line, go until we get the coordinate and extend. So this is 2x minus 1. After drawing these lines, if we have intersections, we have to find those x values of intersecting points. Fortunately here we don't have any intersection. Then consider the inequality. y1 graph, that is this set, must be above y2. y1 must be above y2. y1 is this line. Actually in entire range of x, this part is below this graph. These two lines located below these two lines in entire range of x. So this inequality does not satisfy any value of x. So we can write the set, it is actually a null set. X equals null. There is no single value for x. Question number 6. So in this integration question, denominator is 1 minus x to the power 4. So we can apply difference of two squares here. Factors are 1 minus x square, 1 plus x square. Again for 1 minus x square also I can write difference of two square factors. That is 1 minus x, 1 plus x. 1 minus x, 1 plus x is written for 1 minus x square. The other factor is 1 plus x square. Now we have to separate this complex fraction into its partial fractions. So this is the partial fraction simplification area. For a linear factor we have a constant. For this linear factor we have the second constant. This is a quadratic equation, quadratic expression. For quadratics we have to write linear factors, which is cx plus d. Multiply all the terms by this denominator. Then we have 1 plus 6, x squared plus 1. And b into 1 minus x squared plus 1. And cx plus d into 1 minus x into 1 plus x. What is 1 minus x, 1 plus x? 1 minus x square. Now we can compare x to the power 3 coefficients. Here we don't have x to the power 3 terms. Then we get x to the power 3 by multiplying these two. It is 1x square into a. Coefficient is a. Then here from these two we get x cube minus x cube into b. Coefficient is minus 2. Then once again cx into minus x square we get x cube. Coefficient is minus c. This is first equation. Then x squared coefficient. No x squared term in left hand side. Here we get x squared by multiplying this with 1. Coefficient is a. Here x squared with 1. Coefficient is b. Then here we get x squared by multiplying these two. Cx into 1. Coefficient is c. And also d into minus x square. Coefficient is minus b. This is my second equation. Then x terms. No x terms in left hand side. Here we get 1x term by multiplying these two. That is a. Then these two minus x into 1 minus x. Coefficient is minus b. Then cx into 1. Coefficient is c. This is equation 3. Constants. 1 is the constant in left hand side. Here 1 into 1 will give you a as the constant. Again 1 into 1 will give you b as the constant. D into 1 is. Now we have compared all the terms and obtained 4 equations for the 4 variables that I have written. I can add these two. Then I can cancel only c. If I subtract these two, I can cancel both a and b. So I am going to subtract 3 and 1. Then I get a minus a get cancelled, minus b get cancelled. C minus a becomes 2c. 0 minus 0 is 0. Therefore value of c is 0. Then I can use equation 4 and 2. A minus a get cancelled, b minus b get cancelled. So I am going to subtract 4 and 2. A get cancelled, d minus d becomes 2d. We can neglect c because it is 0. And 1 minus 0 is 1. Therefore our answer d is half. Now we can add these two together to get rid of d. That is 3 plus 4. A plus a, b minus b get cancelled. D is half, c is 0. 1 plus 0 is 1. From this we can get the value of a, that is 1/4. From simplifying these a, b values in 1, we can find b. B is equivalent to a minus c. C is 0, so b equals directly to a. That is 1/4. Now I can express this fraction in this manner using separate integrals. A, that is a 1/4 1 minus x dx. Then b is plus 1/4 once again, that is 1 plus x. Then cx, what is c? That is 0. b is half, therefore it is half x square plus 1 dx. So I can take coefficients out. This is 1 minus x. So here we have to write the differentiation, derivative of
denominator function in numerator.
Derivative is minus 1. To cancel this minus, I will put another minus. Then here 1 over 4. Denominator is 1 plus x. Derivative is plus 1. No change. This is x squared plus 1 square, which is tan inverse minus 1 over 4. Here we have the derivative of the denominator in numerator. Then from the theorem we get the result as ln denominator function. Once again here 1 over 4, same denominator, derivative of the denominator function is in the numerator. From theorem we can write ln denominator function. This is half tan inverse x over square root of constant. Square root of constant is 1 plus c. C is the arbitrary constant. I can take 1 over 4 out and use logarithmic rules. This is x plus 1 minus 1 minus x can be written as a denominator.
1 log expression minus second log expression with the same log base, so I can write them as
fractions. C is an arbitrary constant.
Question number 7, they have given a differentiation question. So this is the function y equal x to the power n e to the power minus x. From this we have to show this equation. So first thing is to differentiate this entire equation with respect to x. With respect to x, this becomes dy over dx. So this is a product. Differentiation of a product. First we have to start from one term x to the power n. Just write as it is and differentiate the second term. So e to the power any function, differentiation of e to the power function is e to the power function into derivative of this index. Differentiation of minus x is minus 1. Then plus, we have to write the second term as it is. Since we have written x to the power n in first term, in second term we have to write e to the power minus x. Then we have to differentiate the second term, which is x to the power n. Differentiation of x to the power n is n x to the power n minus 1. Now we have to simplify this in order to reach our target. So here we can see we have minus x to the power n times e to the power minus x. And here we have e to the power minus x into nx n minus 1. For this part, x to the power n e to the power minus x is equivalent to y. So this is equivalent to minus 1. Then I have dy over dx equals e to the power minus x into n x to the power n minus 1 minus 1. Here we have n minus x common factor y. From this I have to obtain y, because from these two terms I have to take y out. So how to obtain a y term to this part? X to the power n e to the power minus x is y. So I have to make this within this term. E to the power minus x, x to the power n. We know x to the power n minus 1 can be written in this manner. X to the power n over x. Then for this part I can substitute y. Then it is ny over x. Now multiply each and every term by x. Then we have x into dy over dx equals, here we don't have x now, we have multiplied that,
then we get n minus, we have to multiply this by x. We have x and y factor is out.
This is the final answer. Question number 8. Question number 8 is given under straight line section of coordinate geometry lesson. So they have given a parallelogram ABCD where ABC coordinates are given and we have to find D coordinate. So I have marked D coordinate as alpha beta. So if this is the parallelogram, these two lines are parallel and equal in length. These two sides are also parallel and equal in length. So we know parallel straight lines have same gradient. Therefore I can write a logic: gradient m of AB straight line is equivalent to gradient of CD straight line. From this logic I can find an equation for alpha beta. So what is the gradient of CD? We know gradient of a straight line can be obtained by the difference in y coordinates and dividing that by difference of x coordinates. So difference of y coordinates here is 4 minus, this is the gradient of CD, first I am going to write that is 4 minus beta over difference of x coordinates 8 minus alpha. Then gradient of AB 1 minus minus 1, that is 1 plus 1, 0 minus 4. So here we have 4 minus beta over 8 minus alpha equals 2 over minus 4. Then cross multiply, then we get minus 8 plus 2 beta equals 8 minus alpha. Take alpha to this side and minus 8 to the other side. This is the first equation. And consider the same logic for the other two sides. Gradient of BC must equal to the gradient of AD. Then what is the gradient of AD? That is beta minus minus 1, that is beta plus 1. Then difference of x coordinates alpha minus 4. Gradient of BC 4 minus 1, that is 3. 8 minus 0, 8. First multiply. 8 beta plus 8 equals 3 alpha minus 12. Take 8 beta to the other side to make alpha term positive, but I am writing that in left hand side. Then take minus 12 this side. Answer is 20. So this is second equation. Now solve 1 and 2 simultaneously to find alpha and beta. I can multiply first equation by 3 and subtract that from 2. Then I have 3 alpha minus 3 alpha get cancelled. Then 6 beta minus minus 8 beta, answer is 14 beta. Then 16 into 3, that is 48. 48 minus 20, answer is 28. Therefore we get beta as 2. Then from equation 1, if beta is 2, we can see alpha plus 4 becomes 16. Therefore alpha is 12. So what is the coordinate of vertex D? Alpha beta, which is 12, comma 2. Question number 9. Prove that this statement is divisible by 64 using mathematical induction. So mathematical induction is a method of proving a statement or equation which is true or false. The first step is to show the statement is true when n equals 1. So n is the variable here. We have to show this statement. What is the statement? This expression is divisible by 64. So we have to substitute n equals 1. Before that, let me label this as f of n. When n equals 1. then f of n becomes f of 1 is equivalent to 3 to the power 2, n plus 1 becomes 2, 8 into 1 is 8 minus 9. 3 to the power 2 into 2 is 4, 3 to the power 4 is 81. 81 minus 8 minus 9 is 17, and this is 64. So we can see f of 1 is 64, which is clearly divisible by 64. Divisible by 64. Therefore, our statement is true when n equals 1. Then second step is to assume that the statement is true when n equals p. So p is a general value, or which is a positive integer. Assume f of n is divisible by 64 when n equals p. Then f of n becomes f of p, which is 3 square into p plus 1. Instead of n we have to write p. Minus 8p minus 9 is divisible by 64. That means this statement can be written as 64 times a positive integer. If an expression is divisible by 2, we can write that as 2m or 2q, where m and q are integers. So here m is a positive integer. Then we have to show fn is divisible by 64 when n equals p plus 1. Now we have to show the same result when we increase this value by 1. So that is f of p plus 1. So what is f of p plus 1? 3 square p plus 2, p plus 1 becomes p plus 2 minus 8 into p plus 1 minus 9. So we have to show this is divisible by 64. It means we have to express this expression 64 times a positive integer. So the method we have to use after writing this first step, directly write our assumption. Our assumption is 3 to the power 2 into p plus 1 minus 8p minus 9. Now we can see we have done some changes to our first step. Earlier we had 3 to the power 2 p plus 2, but now I have taken 3 to the power 2 p plus 1. So what is the difference? Here we have, when I simplify, I can see in this step I have 3 to the power 2p plus 4. Remove the brackets. Here I have taken only 3 to the power 2p plus 2. So what is the difference? 3 to the power 2 is missing from this expression. 3 to the power 2 is the difference. So I have to multiply this by 3 to the power 2 in order to take the index 2p plus 4. Now, with this coefficient added, these terms also changes. So here I have 3 to the power 2 into 8p, which was not in our first step. So I have to remove this term. 3 to the power 2 minus 8p, so it is a negative term. To cancel that I have to put plus. Again I am going to get another value, 3 to the power 2 into 9, which is also not in our first step. So this is a minus term. To cancel that I have to put plus. Okay, now we don't have this term minus 8 into p plus 1 is not in this second step, which was there in first step. So I have to add that. Then minus 9, which is also not available. So I have to add that. So to write this initial step, I have used the assumption. We can't directly put the assumption, we have to make a small change. After that change, we can see 2 additional terms are going to get, then we have to cancel them. So for this, according to our assumption, I can substitute 64m. So this is 3 to the power 2, which is 9 into 64m. So what are the simplifications of these terms? 9 into 8. So this is 9 into 8, which is 72 e. This is 9 into 9, 81. And here the simplified answer is minus 8p minus 8 minus. Then f of p plus 1 is equivalent to 9 times 64m. Then we can simplify these two. 72 positive minus 8p becomes 64p. Then plus 81 minus 8 minus 9, that is minus 17. 81 minus 17, that is also 64. So here we can see 64 is a common factor. Take that out. 9m minus p plus 1. So this is a positive integer. You can put k for that. So this is 64k. Yeah, k is a positive integer. M is a positive integer. P is a positive integer. Then the summation of this expression is also positive. So we can see our statement was true when n equals 1. Then we assume that is true for p. Based on that assumption, we have proved our statement is divisible by 64. Our statement is divisible by 64 when n equals p plus 1. So according to mathematical induction theory, we can say f of n is divisible by 64 for all n element of positive integers by principle of mathematical induction. Question number 10. This question is regarding applications of integration. So here we have two functions. You have to change the angle of this function. It is cos x, not cos half x. So we have to obtain the area bounded by these two functions, and x equals 0 and x equals pi by 2. X equals pi by 2. So initially we have to draw the functions. So sin 2x, substitute 0 for x, then we have sin 0, which is 0, then sin 5 by 4, then this becomes sin 5 by 2, sin 90 is 1, then second value 5 by 2, it is sin 2 into 5 by 2, which is sin 5, sin 180, it is 0. So this is the first part of the first graph of the fx function. Then g of x is cos x. Then substitute 0, it becomes cos 0, which is 1. Then substitute 5 by 4, cos 5 by 4 is 1 over root 2, somewhere here. Then cos 90 is 0. In the second graph, like this. Then the area bounded by these two. So you can see when we take f of x, this is the
area bounded by this curve, area below this curve. Then area of cos x, this area below the black line. Then when we subtract these two, the remaining area is this. So we know this area is starting from this point of intersection, which is alpha, and ending at pi by 2. So when we increase our range to 5, so we can obtain another portion similar to this, kind of a mirror image in this part as well. So there also we have to find another point of intersection from this quadrant. So since we have to find 2 points and it takes more time, I have reduced this range to 5 by 2. So how to find alpha, this point of intersection? For that I have to simplify or solve these two equations together. Sin 2x equals cos x. Apply 2 theta formula and take cos x to this side. Then cos x is a common factor. And I can take cos x equals 0 and sin x equals half. From this equation x becomes 90, cos 90 is 0. Here we get 30. X equals 30. So this angle is 30, is alpha. Then to find the area enclosed by these two functions, I have to integrate. The larger function, which is f of x, and subtract the integration of minor function g of x from range alpha to 5 by 2. Starting point is alpha, finishing point is 5 by 2. From this I can obtain the area. So what is alpha? 5 by 6, 5 by 2. F of x is sin 2x minus g of x is cos x. So we have to integrate this. Sin 2x, integration of sin is minus cos 2x over differentiation of the angle, which is 2. These are the limits. Minus integration of cos is sin divided by derivative of the angle, which is 1. Then the limits 5 by 6, 5 by 2. And here we get minus half cos 90, substituting the upper limit. Here we have 2x, so 2 times 90 becomes 5. Then minus times the lower limit, which is cos 2x into 5 by 6, which is 5 by 3. So here in the function also we have a negative sign, so this becomes plus. Then minus sign, substitute the upper limit, minus sign lower limit 5 by 6. This minus have to be multiplied by this minus sign, so this becomes plus. So what is cos 5? Cos 180, which is minus 1, plus half into, this is 60, cos 60 is half. Then sin 90 is 1. Sin 30 half. Here we have plus half, here we have 1/4, minus 1, it's again half. Half plus half, 1, get cancelled with minus 1, answer is 1/4. So this is the area bounded by f of x, g of x within the range 0 to 90. So with that I conclude my paper discussion.
So I have discussed 10 short questions. I hope to discuss 10 more questions. Keep in touch, subscribe my channel and like and comment these videos. Thank you.